Alright guys, welcome to this page of the notes. Here we go. We got 3 theorems to go through, and our first one is going to be the intersecting chords. So, here's the way it's going to work. Just like we had in the last section, we're going to have chords inside of a circle, and those chords are going to intersect. Let me quickly remind you of what we did in the last section. In the last section, when we saw this chords intersecting inside of a circle, we had what we called the chord product theorem. And remember the way that the chord product theorem worked. What it said is the chord product theorem helped you find a segment, a missing segment. And so the theorem said this: I have 2 chords. I have chord AD and chord BC. They intersect at E, and it breaks it up into 4 segments: A, E, E, D, and then B, E, E, C. And if I multiplied those chord segments together, they had to be equal to each other. So it was A, E times ED, so AE times ED, that had to be equal to BE times EC, right? And so, in the last section, if you didn't know one of those segments, you could use the chord product theorem to solve for an unknown segment. So, this guy finds a missing segment. But in this section, we want to find missing angle measures. So here's the way our theorem is going to work now. If you have intersecting chords, but you don't know an angle, I want you to find this angle right here. Oh, hang on, that's ugly. This angle right here. Boom, that guy. I want you to find that angle. What is the theorem that we're going to use? Well, it works like this. The measure of this angle, the measure of angle 1, is going to be equal to 1/2 the measure of arc AB plus the measure of arc CD. So if this is AB, sorry, not highlighter, I want my pen. AB, this is CD. You will simply add together the measure of those 2 arcs. Add them together, multiply by 1/2, and you'll find the measure of that angle. Couple of quick notes about this theorem. First, addition is commutative. Actually, here, you know what? Rather than that, I'll just simply put this. Order doesn't matter. Okay, you can do arc AB plus arc CD or arc CD plus arc AB. It doesn't matter. You're going to get the same answer. Addition is interchangeable. Order doesn't matter. You can do it in any order. It's commutative. The other thing is this. Right? It doesn't have to be this angle. Please notice vertical angles. Whatever this angle is, this guy is the same. Those are vertical angles. So it doesn't matter which one I ask you to solve for. I can either ask you to solve for AEB or I can ask you to solve for CED. It doesn't matter. They're the same. Angle AEB is congruent to angle CEB. So please don't think that this theorem only finds you that angle there on the left. It doesn't. You can use the exact same theorem to find the angle on the right. Why? They're vertical angles. They're the same. They're congruent. All right, so just a couple of quick things about this theorem. It's not as tricky as it appears. Again, interchangeable, and it doesn't matter which angle. Both of those angles are exactly the same. You can find both of them using this theorem. So let's go ahead and get a little bit of practice. I got some problems for you right here. Okay, Here we go. I want you to find, what do I ask you to find? I ask you to find MPK. Where is MPK? MPK, I want you to find this guy right there. I want you to find the measure of MPK. All right, well, here we go. Here's what the theorem says. The theorem says that the measure of angle MPK is equal to one half the sum of the arcs, right? What arcs? These guys, KM and NL, right? Those two, actually here, I don't want to do them in the same color. Let me switch. I'll do green for this other one. And again, the order doesn't matter. You can do KM plus NL, or you can do NL plus KM. It doesn't matter the order. Addition is commutative. So here we go. It's going to be the measure of arc KM plus the measure of arc NL, or vice versa, the measure of arc NL plus the measure of arc KM, whatever, it doesn't matter, you won't screw it up. So here we go. The measure of angle MPK is equal to 1/2 61 degrees plus 111 degrees. Don't fat finger something on your calculator and you should be good. 61 plus 111 is going to be 172 degrees. You will divide 172 by a half, by 2, divide by 2, or 172 times 0.5, whatever, the exact same thing. You wind up with 86 degrees is the measure of angle MPK, which is exactly what I asked you to find. Let's do another one. Here we go. I want you to find arc PR. So I want you to find this guy right here. Find the measure of arc PR. Well, here we go. Here's what I know. I have intersecting chords. So the measure of the angle, so the measure of angle QTS must be equal to 1/2 QS plus PR. Alright, here we go, right? The measure of the arcs. Well, I know QTS is 58. So we have 50, oh, hold up, there we go. 58 degrees is equal to 1/2. Let's see, QS is 82. Plus, oh, PR, I don't know, that's what I'm solving for. Okay, fantastic, we got a little bit of algebra to do here. First, I'm gonna need to move the 1/2 to the other side. Since I have division by 2, I'll need to multiply the 2 to the other side. I get 116 is equal to 82 plus the measure of arc, PR. Subtract the 82 to the other side, and so the measure of arc PR is equal to, I get 34 degrees. And so there you go. Whether I have you solving for, up here, check it out, look, my formula right up here. Whether I have you solve for the measure of the angle, or if I have you solve for the measure of one of the arcs, it doesn't matter. It's just algebra. You're set. The geometry is the formula. Algebra lets you solve for whichever part you don't know, right? If you don't know the measure of the angle, okay, find the measure of the angle. If I don't give you the measure of one of the arcs, fine. Algebra will allow you to solve for the unknown. The geometry is the formula, setting up the formula. The algebra is solving for the part that you don't know. So our first theorem is going to be this one, the intersecting chords angle measure theorem, which is related to what we did in the last section, the chord product theorem. So if I give you this guy and you don't know a segment, chord product theorem. If I give you this guy and I ask you for the measure of an angle, you'll use the intersecting chord angle measure theorem, right? They go together from the last section to this section. Those two go together to help you solve for an unknown, either an unknown segment or an unknown angle measure. Head on over to the next page of notes. We'll take a look at our next theorem, and I'll meet you guys there.